2532. It says the energy barrier for rotation of a CH2 group of an allyl radical is about 66 kilojoules per mole. So it's saying if we've got this to rotate this group CH2, CH2. This one is also CH2. This is CH. These CH2s are actually equivalent. We'll talk about that in a second. The CH2 group, to rotate around that, it takes about 66 kilojoules per mole. The energy barrier for rotation of CH3 group in propane is about, 14 kilojoules per mole. Explain this difference. With the big notice or thing that we're noticing here is that this is more, this is more and this is less. And so it takes more energy to rotate around this barrier. That's because we have resonance for this. And so I'm going to erase this rotation arrow and just show you the resonance so we can see why that's a little bit harder to do. If there's a radical here, that radical can be stabilized by moving it into the double bond and moving another electron into it to make a double bond between here and this moving out onto this position. Because we have those two resonance forms that are equivalent, we have partial double bond character on that position. So either one of those CH2 groups, whether it's on this side or this side, is partial double bond. It's really difficult to rotate around double bonds, which is why we see a much higher energy barrier. Does that make sense?
Can you go through that again? I don't know if it's my computer or you, but you were freezing there for a little bit, so I didn't catch all that.
Yeah, absolutely. So we're talking about the difference between rotating in this molecule and this molecule, this one being much, much higher. This molecule has resonance structures where this electron can be stabilized in a double bond if we borrow one from the neighboring double bond and have the other electron go over here. So these are the two different resonance forms of this molecule. And since we have double bond character here on the left side and on the right side, both of those CH2s here and here have a higher energy barrier to rotation because they are part double bond, and it's really difficult to rotate double bonds. Did that come through?